Good afternoon. Sorry for all the wonderful confusion. It's one of those cases where my laptop only has USB-C, they have a VGA, and we've passed through 14,000 different plugs and nothing worked. So we ended up having to rework things a little bit. Hi, I'm Dave McAllister. I'm from California in the United States. As for the keynote after lunch, I know about 4 words of Spanish total. I can read German pretty well. I can get along in Japanese, but I've never managed to pick up Spanish, in spite of living in California. So what I'm going to do is talk a little bit about today is this concept of called RED monitoring. And I want to talk about it and how it applies to the new complex worlds we've got involving Kubernetes, involving microservices, containers, as well as this larger picture of this thing called observability. And to kind of start with that, there we go. This is actually a quote from a Sherlock Holmes novel. You see, but you do not observe. And it goes to the fact that we tend to look at things that we can see. And we forget that we've got a lot of other activities that may be going on underneath the surface at all the various times. Sorry for the slight delay here. But you're actually now looking at a deeper picture. And one of the things that happens in this world of microservices is that you have to be very careful not to jump into this water unless you know what's underneath as well. So, to start with, observability is what's called a signal to noise problem. Actually, it's a signal with noise problem. And there are 2 ways, back in my old hardware engineering days, there are 2 basic ways that you can reduce noise inside of here. First of all is you can filter on the front end. You can only bring in certain pieces of information and analyze those. The second is you can analyze those pieces and throw away the pieces that are noise at the back end. There is a third option, which is what you really end up having to look for when you get into this larger monitoring for microservices, and that's to keep everything and figure out how to make the best sense out of both the signal and the noise. What happens is we see a lot of times is that people throw away the stuff that they consider noise, but it's actually the stuff that really matters to them. Microservices, this little thing over here, is actually a very small example of an e-commerce microservices environment. This is actually just the front end of that e-commerce microservices environment here. Quite often, where something goes wrong has nothing to do with the service that reported the error. It can be somewhere else in that entire chain. So, the shorthand version of this is observability really is a quality of the software, the services, or the products that allow us to know what's happening inside of our systems. Observability comes from machine theory. Machine theory basically says it's how you figure out what's going on inside of the machine by looking at what you can see from outside. In cars, for instance, we have temperature gauges. They can go up to high. We know that we need to turn our car off. We plug in to the computer. We get more information about what's going on, whether we're out of water, whether our fuel pump has failed, whether there's some other activity inside of here. But this is a way of looking at it. You have to think about this from an application design viewpoint. What things can you expose that make it possible for you to know what's going on inside the system? Applications are black boxes. The only things you get to see are the things you pass outward. So, when we look at this, though, it's not one-dimensional. It really does consist of lots of different elements. And usually they do get broken down into monitoring, into tracing, distributed tracing, and into logs as the 3 pillars. But there are lots of other pieces of information. I had a client just recently who their application is 1,500 cores. So it works out to something around an order of 425 virtual nodes inside of Amazon. And they noticed from a monitoring viewpoint that their overall systems were running about 1.6% slower. Nothing triggers, nothing that makes it important to see inside of here. But they had one customer whose data was no longer going through. And when they started digging down into that, they looked at all their principal sources. Nothing really showed up in the monitoring except this customer was at 0 for this. Nothing really showed up in the traces, except the traces were taking forever for this one customer. And nothing showed up in the service logs or the application logs. And we actually had to dig all the way down to figure out what the threads were doing inside of the cores to figure out what was going wrong with their system. And it turns out that they had done an update. Somebody had changed the configuration, removed the variable that controlled the queue depth for the thing to know to expand to an elastic search. The queues were filling up, throwing away everything that was going out. At the same point in time, the customer had changed his data source from long files with relatively few to very short files at roughly 100 times the performance rate that was going through. So he was filling up the queues before the queues could respond. And the only way we found it was actually by going all the way down to see what the threads were doing inside the CPU. You cannot have enough data. But by gosh, anything that slows you down is bad. Google survey in 2017 for an e-commerce site, generalized e-commerce site, 5 seconds is a lost sale. People will walk away. 10 seconds is somebody who will go complain to their friends about you on social media and will not come back. If you go over 5 seconds, 127% of your customers will not return to your site. They will find some other place to do this. So we can't wait for these results. That little thread problem took us 2 days to figure out what was going on. So, observability is actually an attribute. It's something you design for your system. Monitoring is a verb. There aren't these 3 pillars. There are lots of things that can happen here. You need things you've not even thought of yet, and you're going to get data that you haven't ever seen before at the same time. Observability is really around the unknown unknowns. Monitoring is around the things we expect could go wrong. Observability is finding the things that went wrong when we didn't expect them. And they do walk down into this category, again, of the metrics. Do I have a problem? The traces, where is the problem? And then finally, the logs, what's causing the problem? But you actually need all 3. This is a dimensional problem. You're going to need all 3. If I look at you and said, the rate of error is 100 per 10 seconds, it does not give you any information inside of that. And each piece down gives you more and more information about what's going on. So, excuse me, I'm actually awake, which is really kind of scary for me being in Europe. It's now bright and early in my morning time frame, so I'm wide awake and ready to go here for this. So you'll also hear this thing called events. And events can mean lots of different things. In some cases, they mean semi-structured logs. But generally, actually everything is an event. The trick is that nothing exists unless you record it. You know, in English terms, if a tree falls in the forest and nobody hears it, did it make a sound? If nothing records it, it doesn't exist inside of here. So we have to be able to build these things. That gets us into this cardinality problem. We have more data that we can deal with. How do we keep in track it? And so metrics are really compact. I can aggregate up and I can tell you there were 100 errors per 10 seconds for here. But it doesn't really tell me what went wrong here. Traces or logs are full fidelity. Logs will give you every piece of information you ever wanted to know, as long as somebody wrote a good log. Again, not the last client, previous company. One of our engineers thought he would be clever and cute. I hate to say this, but he interspersed his logs with writing Russian, as well as writing logs that goes, "Here I am," and that's all it said. And so nothing really helped us when we looked at the log files for here. We did make him go back and do translations for us for that and replace all of his "here I ams" on this. Traces, on the other hand, are really cool. Distributed tracing is the coolest thing known to mankind right now, and I love getting into distributed tracing, and I can talk for hours on distributed tracing for this. It requires instrumentation of some sort to make it work, and it makes logs look like they're really lean and mean. A single request driven through a microservices environment, a single request may write, 7 log entries, 8 log entries, maybe. Every log entry will be between 20 to 30 trace entries. So all of a sudden you've got an explosion of data that's happening going across that entire model. blip. Most of this world really does concern ourselves with this far, my left, your right, end here. When we were back in the world where we sort of had the monolithic viewpoint, one server, one system, a couple of connections, we didn't have to worry about the detail and the complexity we got there. As we move over to this containerized world, this orchestration world, microservices, where things are loosely coupled, where we can end up with more elasticity, more systems coming and going, ephemeral behavior, where things exist and don't, we suddenly start running into, we need the capability of looking deeper inside the systems for that. And this is an example of a microservices just off of the Amazon page for a book. And inside of this, you can see there are multiple, of course, lasers don't work. Oh, it actually works pretty well on this one. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, just on the entry page alone. Behind this is all of the actual e-commerce stuff. If you're buying something with a foreign currency, it's got to do the exchanges rates in here. It's going to check your bank. It's going to make sure you own your credit card. It's going to do all those pieces inside of here. So the system becomes a very complex microservices environment for that. Know that y'all are quite familiar after watching the hands go up around Kubernetes, but quick handle on the Kubernetes side for this. So Kubernetes is container orchestration. That's what it's designed to do. First came out, the first version after with CNCF, Cloud Native Compute Foundation, was July of 2015 for this. And I've forgotten what version we're up to, but they're about to release a new version if they haven't done that this week for here. There are two basic parts that happen inside of here. There is a control plane viewpoint here, and then there's the infrastructure viewpoint that happens. The control plane makes sure that things match what you want them, the desired state here. Inside of this infrastructure, we have worker nodes, we have pods, we have containers, and then we get down to our apps. So we've added more levels of infrastructure on top of our environments just to go to this orchestration model. So again, now you're not just worrying about the application complexity, you're actually worrying about a whole new set of infrastructure complexity, all happening inside the same thing. And things start and stop. Things are not where you necessarily think they are. In fact, Kubernetes is really good about not telling you where it puts things. The nodes and the pods will, but Kubernetes won't inside of that. So you need to watch all of those different pieces of information as they cross those various boundaries for that. And then similarly, ephemeral behavior. Things can start and stop constantly. Things that stop badly are not really good. But even then, if you go into a serverless environment, AWS Lambdas, serverless environment, a Lambda cold start is 400 to 700 milliseconds depending on the length of which language you choose. A warm start is 38 on average, 38 milliseconds. If you're only picking data every second, you're missing a whole lot of potential Lambda events that are happening inside of here. So now we have that complexity, we have things happening faster than the blink of an eye inside of here, and we need to be able to track back to what's going on at all times. Because when the pod stops, unless you recorded that data, it doesn't exist anymore. It's gone. So you've got to be able to track all that piece of information and keep track of them. Again, if you don't record it, it doesn't exist. So keep that in mind when you're looking at that. And then finally, the last part on this observability thing, if I remember correctly, is that observability right now is considered as a straight line. I see it, I say something. It shouldn't be. So in machine theory, it's actually a duality. So the duality of observability is controllability. The way we get signals is called telemetry inside of here. But we need to be able to start closing this loop, see something, do something, instead of simply saying something inside of here. Loops can be open or closed. You can automate a loop, response back. We set up an automation system that we have a customer that when they roll out their Canary deployment, if they see something going wrong, the system will immediately roll back to a known good state. Uses whichever one. It's not Jenkins, but it uses that, makes a call out. The minute it sees something out of the ordinary, it doesn't even know what is out of the ordinary. It looks at the historical data and says, this doesn't look right. roll back, let me know, and keeps them up and running on all those cases here. An open loop is a person in the middle. So that's where you get an alert that comes back and says, something's gone wrong, come fix it for me. So closed loop and open loop is what observability really kind of needs to work towards. So why this RED thing? So why RED and Kubernetes inside of here? Well, complexity really does matter inside of here. We have a lot of moving parts. We have a lot of relationships that are happening inside of here. We don't know where these pieces all are. We're not even sure necessarily what order things are operating in at any given point. We need to be able to have the simplicity while being able to abstract out for this to get rid of that clutter, that noise that's showing up inside of here. And at the same point in time, we need to have that complexity so we can find out the things that went wrong that we didn't know went wrong. So that's the complexity. Grab those moments when something went wrong that you totally didn't expect to happen. This actually happens a lot in microservices. And it usually is not the piece that's reporting the error. It's usually somewhere else in your system. Not always. I've seen it happen multiple ways, but quite often you'll see something that's causing errors to show up and has nothing to do with what's reporting the error. I've almost got the timing down right on the screen here for this. And so what is RED? RED is a subset of what was called the Google Golden Signals. And Golden Signals was their SRE. It's in the Google SRE handbook for this. And Tom Wilkie, who was at that point in time with Weaveworks, came up with a subset that was designed for a microservices environment, which he called RED. While it was very microservices focused, it turns out that it actually works for anything that's request driven. So if you've got e-commerce, if you've got a unique identifier that goes from point A to point Z in between, RED actually works really well for here. It's made up of 3 categories: rate, errors, and duration. And those 3 categories roll up information to give you a basis for all these various pieces. As an example, over on this side, my services are showing up here. I have the rate in which they're happening per second. I have an error rate, and there's obviously something going wrong inside of here. I can then look at duration from a percentile basis, and I'm showing the 50 and the 90 inside of those 2 pieces. That type of information will tell you a lot of different things. This particular application, the little circle says, I also fired an alert. Interestingly enough, the issue is not here. The issue is actually down here with this database. Someone, when they were looking up the catalog, failed to put the limiter into the catalog that says, I just want you to report the thing that I asked for and put in a star. So the catalog was trying to return every single piece of data in the catalog, every single catalog call. Needless to say, that takes an amazingly long amount of time to do that. It's even at 10 requests per second. If you're returning the entire catalog every single time, it takes a while for that. So basically, you can think of it this way. Observability starts with, it may not be purely monitoring, but it starts with monitoring. And it's monitoring on what commonly gets called the Chuck Norris level. Take an action inside of here. Be able to do those things. It still does break down, you can look at this as metrics are driving the rate, logs are driving the errors, traces are driving the duration, and it helps with these 2 basic issues here. Find out what's going wrong, where the issues are, and look at what the root causes are. So it helps you drill into those pieces very quickly. Rate, obviously, requests per second going through the system. It can be HTTP requests, it can be SOAP requests, it can be the control structure of a service mesh like Istio, Envoy, or Linkerd. It could be any of those different pieces inside of here. Anything that can fail on rate is a target for a RED type of environment. Note the word fail. I want to point out that fail doesn't mean too high. Fail can also mean too low. In July of 2018, Amazon's Prime Day started off with them flipping the switch and not being able to take an order for 5 hours. 5 hours. So roughly speaking, that's $336,000 per 10 seconds, if I remember correctly, for what happened. And the reason they actually noticed it was that the alert triggered because their rate went to 0. And not that the rate was too high, the rate was too low for this. And so it becomes interesting to be able to note what's happening on both ends. We can do this as sudden, unexpected changes. By the way, what happened was somebody rolled out a new version of a microservice. They had tested it, but testing for production is not testing in production. And testing it on the busiest day of your sales year is probably not the best place to start your testing side of here. And it took them 5 hours to recover from that because they had backed up their queue systems, they had backed up the front ends, and they had to process all that data through before they could get back to normal. Needless to say, Amazon Prime Day in 2019 had 0 flaws. It worked like a charm. Apple Store, on the other hand, in 2019, did the exact same stupid thing. They launched a new product, new process on the day of Prime Day, and they flattened themselves. They were only down for about an hour and a half, but even that's pretty expensive. So, example, you'll see this again. So we have a rate indication. We can see kind of how the rate is varying across these pieces. We can look at this and actually start telling, if you click into here, you can actually start telling what's driving most of this rate inside of here, which pieces are driving. This is called an aggregation. So, and we aggregate up to get this metric. We look at the number of requests that are going through here, we aggregate up. Disaggregation, pulling it apart, is actually just as important as seeing the first number. So being able to break it apart and say what's happening with each of these pieces also becomes an issue. Errors, pretty obvious, things that give an incorrect result, things that are incomplete, things that never come back, all are examples of errors in here. And these are pretty standard. We all fought bugs in various pieces of code here, and they require things to be solved right now. In this world, we're an instant gratification society. People looking at their phones, doing responses. If your phone buzzed at you in a particular code, if mine buzzes 3 times, it's my wife trying to figure out why the heck I'm not back where I'm supposed to be. For here, you look at your phone. We're instant gratification guys for this. And so errors require very fast responses. They also require deep dives. And this is where you get into log files, looking at the log information, finding out what's going on. By the way, even though it's called RED, the order you're going to search this is actually RDE, but it doesn't spell anything, so RED became the topic. And very honestly, this is something you need right now for that. Errors are a very similar structure. You see the percentage of errors that are happening inside of here. You can see the rate that errors are happening over a time period, and then you can see the spikes in terms of the endpoints that are happening crossing those various pieces. And in this particular case, at the particular point that's clicked here, my error rate is 54% of my requests going through at that point in time are failing, which is actually a pretty high number, I would say. I think the alarm is set for 1.5% error rate. Duration is the last piece that we talk about here, and this is all about time. And its rule is to do 2 things. Show you the pathway that your application's request took going through the system, as well as put things in order so that you can actually see what happened in their steps that are going on in here. And it's going to answer questions like, how long did it take from start to finish? How long did each piece take in between it inside of here? And then which pieces were slow? And then which service was responsible for that slow piece? So what happens is you'll get a metric response. Something's gone wrong. You usually drop into the traces and say, so what's out of the ordinary on the trace? And you'll usually see some sort of spike activity up or down. You'll see a flattening. You'll see something strange that's showing up inside of here. And by the way, the good news is that most of the tools, the open source tools, the closed source tools, they all actually do most of that work for you inside of here. And then you drill into the logs specific to that time region, because logs are time stamped, so that you can actually start looking at the specific details of what caused that specific problem to happen. And generally speaking, this falls under distributed tracing. So distributed tracing has been around for a long time. Well, we now have a fairly good set of de facto standards for this: open tracing, open census, and open telemetry, which is the combination of open tracing and open census that are coming out here. Again, the easiest way to do this is to get an instrumented library. and just drop it in. There are lots of instrumental libraries, particularly for open census right now. Open telemetry's got 2 or 3. Open tracing's got a handful more. Each piece of those pieces has a different functionality and capability. Your mileage may vary. Open telemetry puts the two together, and it will probably become the de facto standard probably by the end of this year, in fact. So those are the pieces. Tracing's been around a long time. I can build your traces out of log files for this, but distributed tracing does all this massive amount of work for you that you don't have to worry about and protects you from vendor lock-in. Sorry, yes, I do work for a vendor, but nonetheless, it protects you from vendor lock-in. You can take your open tracing from tool to tool because it's the same model. And tracing kind of looks at an aggregate level, at the red level, like this. What the average duration over a time period is here, how that time period breaks out for the endpoints of interest inside of here, and then what the latency by percentile looks like. Clicking on any of those points, you can drop directly into the trace itself. Dropping into the trace itself will give you a specific point in time. Good tools will let you click on that point, drop it directly into the logs. So you can actually drive each of those pieces that way. So why RED? Well, Tom points out it's easy to remember. And since I've spent 3 or 4 days getting really well introduced to Spanish red wines, I'm really in favor of that for this. It reduces something called decision fatigue. So one of the things that we see when we go out and talk to customers about this is that we have lots of groups going, oh no, I need this piece, I need this piece, I need this piece, and everybody suddenly goes in there and nobody makes a decision. RED gives a common starting point. Really simple. We're going to give you rate, error, and duration. From rate, error, and duration, you can break down to anything you want to, and you can expand it to anywhere you want to. But everybody is going to have a common language so that if you have an ops team talking to a dev team, they basically both know what these two pieces mean. And that's really important in distributed teaming. It's very important in microservices, where microservices tend to specialize in their service approaches here. It also is a proxy for user happiness. And I'll touch on this a little bit more, but think of it this way. Users are really interested in how long did it take and whether I was successful. And that's really what they're looking for. And RED will tell you in aggregate how happy your customers are. Maybe not an individual customer, but your customer happiness, well, it shows up inside of that. So now for the downside of what happens in RED. Okay, we have these 3 things, rate, error, and duration. Any one of those 3 or 2 of these 3 can affect either of the other 2. So it can't just simply look at this and say, oh, look, I have a slowdown. My slowdown can be caused by a lot of different pieces inside of here. So my duration is running slow. It could be an error in a microservice. Very honestly, it could be very simple. You've got a bad microservices. You have what's called a slow consumer now, and all of a sudden it's backed up. It can't process requests that fast. It could be your network. It could be a bad network card. It could be the fact that Kubernetes has crashed on you and is no longer giving you the number of nodes, pods, and applications that you expect. So it can be a lot of different pieces inside of here. So rate can be affected by errors. Rate can be affected by duration. My duration's gone up, my request rate went down. I don't have as much bandwidth. To quote John Massey, a computer scientist from the 90s, bandwidth costs money. And so people have limited sets of bandwidth inside of here. So each of these pieces can affect each other in different ways. And this is where you start getting this multidimensional approach here. This is where you look at the 3 categories and you can pretty quickly, literally within 4 hours of watching your system, pretty much be able to tell exactly what's going on. Again, we now have machine learning tools that will help you even pinpoint what's going on inside of this by looking across all 3 boundaries. So that's something you actually will hear me very seldom say. This is actually one of the few times that I've found machine learning to actually be useful is in this RED environment. It's useful because it's simplified and it's not trying to solve point-specific problems. It's trying to guide you to the right places, and it's actually pretty useful for that. So Some challenges that happen, and this is sort of the real world thing here. Quite often, people look at this by either its infrastructure or application. You know, as we talked about with Kubernetes, it's not an or, it's an and. It's infrastructure and application space. They both impact each other. You're going to be in very complex environments. You know, don't depend on raw data. Make sure that your tools are capable of helping you inside of here. And if you should be a can't, if you can't drill down, don't bother. Don't go with a tool that only aggregates up. It will not do you any good inside of here. The only people who will ever be happy looking at a dashboard that can't be broken down is the executive team. They'll be perfectly happy to say everything's working fine. Then the minute something breaks and you can't figure out what's broken, they're going to be equally unhappy here. So RED in monitoring uncovers problems in microservices that under Kubernetes that you may not actually see. Generally speaking, I'd show you a little 2-minute demo, but no laptop. So that's not going to happen in this time for this. So sort of the philosophy side. I always put in at least one philosophy set of slides here. I ran a nonprofit called Philosophy Talk for Stanford University. The hardest thing in the world to do, by the way, is get 2 tenured professors of philosophy to agree on anything, even if they're in total agreement. They will always argue the point forever for this. So basically, when you're looking at this world of complexity, and what RED's going to help you with here is that user external view. Users are really interested in the request, its success, and how long it took. Operators' viewpoints, and in a sense, the dev's viewpoint inside of here also is, I'm worried about the request, the latency, how many of them, the concurrency that's going through here, and then I'm also worried about the system resources or the components that's being used inside of all those pieces. And RED actually gives you the view into both those worlds. So RED's going to give you a view of what's happening in your overall system. Each customer is going to have a slightly different experience, but if something goes wrong, RED will catch that for you incredibly fast. So instrumentation by itself is not the answer. It'll help you find the answer. So keep that in mind when you're looking at this. You're still responsible for figuring out the answers. Just instrumentation will make life a lot easier inside of here. Metrics are really powerful. We can do lots of metrics. You know, there's tools on the marketplace that literally talk about how they can run 100 million metrics per minute through their system without even blinking. They're talking real-time live data feeds all the time over here. None of us are going to sit there and watch a stream of 100 million things per second, per minute, scroll past the screen. So for that. Also, we've got to be able to break it down. Metrics will tell me that I've got 100 errors, but it doesn't tell me where they are inside here. You want to look at the work that's going on, not the services. You're going to watch the services anyway, but think about what the workload on those services look like and how the work progresses through your services. In that case is where distributed tracing is going to build you a service map. You can actually take down every single request and look at how it transfers through your system. That's going to give you a service map. You're now going to understand what the flow through the system looks like. It used to be real simple. Mainframe, database, middleware, front end. It was pretty easy to figure out what the flow was through here. Microservices environment, you have no real information unless you can build a service map for here. And your goal is not observability. I've talked a lot about observability, but that's not your goal for this. It's how fast you can find something went wrong, how fast did it take you to respond, and then how fast did it take you to resolve the issue. Again, as long as things are running good, you're going to be perfectly happy. And honestly, we want things, I looked at the engineer for our cloud environments and looked at him and said, what would happen if our product was only up 95% of the time? And he said people would be fired because down 5% of the time is not acceptable for here, which means, you know, 99.99, 1/100th of 1% is sort of the acceptable range for downtime. And that's when you're going to worry about this type of stuff. The problem is when you get to one of these pieces, you're going to be able to dive deep into it. That other 99+%, And that's where those red dashboards are going to tell you everything is working just fine and you're home free for that. And finally, observability is more than monitoring, but it starts with monitoring. It goes from monitoring to action inside of that. And RED really does win for a starting point for these microservices organizations. It makes it really simple for everybody to have conversations inside of here. It simplifies what we do in a Kubernetes environment right here. And the caveat is it can do things that you don't expect. So keep in mind that there are interesting interactions between the RED metrics and monitoring structures and what's actually happening underneath of it. And then finally, find the right tool. Find the tool that fits your needs. Don't just accept that the tool that somebody says is going to work is going to fit you in all cases. And with that, I have 2 minutes. I have 2 minutes. Yeah, that's why I'm closing up. So thank you very much. I appreciate y'all sticking with me to this end of the breakout sessions. And let's go enjoy the keynote. Cool.